Okay, we are live. I'm starting the event as well. Okay, perfect. Can you check if the live is started? Just 1 minute. Okay, perfect, Arturo. We're live on Instagram, on YouTube as well.
Cool.
Okay, great. Thank you so much for joining this live event.
It's a pleasure, as usual.
I appreciate your time. These webinar series are perfect. And during this pandemic time, people are really looking for inspiration and looking for something to learn. And talking in this way and learning and teaching virtually to the people and to the seekers of the information would be great. Thank you so much. I really appreciate it.
Really, my pleasure.
Would you? The mic is yours if you want to say hello, anything to our followers.
Yeah, hi guys. It's a really great pleasure to be here. I think this is an important moment to stay together and share our passion, our skills and knowledge also in the same time. But it's important to stay together because we are a community, and in this moment, actually, we are really discovering the importance of like virtual communities, like parametric architecture, for example, which is like is our home, is our daily home. If you think about it, I mean, because every day we check your page, and it's important for us to stay together. And it's really my pleasure to be here with you and with you guys.
Thank you so much. Thank you. And we're also live on YouTube. And you guys can easily write your questions right over there. We're watching the questions over there. If I see anything that should be asked from Arturo, or you can ask also from me, we will just ask the question. Arturo will answer, or I will answer. So feel free to write your questions. Okay, Arturo, what do you think? What do you think will happen with this situation with Corona?
Well, I don't know. You know that I'm in Milano. I'm in Italy. Situation is getting better. Fortunately, I stay positive. I still stay positive. No one can, predict what is going to happen. Of course, the market is changing slowly, but it's changing. Our professions will change in somehow. We are like exploring new way to like cooperate, to work, to find new jobs. For example, this is for example to me is one of the next challenges. For example, how to get new clients in a way, if you are a professional in a situation where you cannot travel as it was in the past. In a way, we will test our resilience. I know probably this is very trivial, but I'm sure that we are really going to test novel ways for not only for present ourselves, to communicate our ideas and our project, but also to radically change the way as architects or as designers we work today. And once again, also finding new work opportunities in a digital realm without real interaction. And I believe in real interaction actually, but we will try something new also in that field, in that direction, let's say.
Great. I'll go to discuss about parametric and computational design. In the last 20 years, how do you think it has impacted the design profession, like architecture, interior, jewelry design? And you also yourself are very investing and doing really great job on industrial design as well, product design as well, like shoes, like cars, like installations. What do you think in the past 20 years, does it have any big impact, or it was on the train, we should just go in this way?
If you remember, we had a discussion, let's say a couple of weeks ago, and I was doing a kind of analogy, if you remember,
Yes.
about computational designers and
Yes.
music producers. We are
Right.
broadcasting from parametric architecture, and I think that parametric architecture, but architecture and design, industrial design in general right now, is not possible without this kind of key figure of computational designer.
Right.
And I was talking about the music producer. I'm a music enthusiast. I'm not a musician. I cannot play any instrument, but I like music. And I was thinking about if you analyze the history of music, for example, of like the last century, from Brian Eno, from
Right.
David Bowie, and is the collaboration with Brian Eno in like epic albums like Heroes, for example, or if you think about the collaboration of Michael Jackson with Quincy Jones over the 80s, and recently Radiohead with very important producer like Nigel Goldrich, for example, you can see that nearby the artist, you can see kind of figure which is more technical, which not only has skills in terms of, in that situation of like music skills and technical skills about sounds, about how to control the production, the recording, and so on, but also talent, also a vocabulary, a vision, everything blended together with music culture in this case. And in my analogy, I'm basically describing the quality of the computational design today. So I was saying technical skill, vocabulary, vision, and design culture in our case. This kind of collaborative environment led in the music industry to masterworks, but it's also happening in architecture today. I think if you like check the latest architecture or the latest automotive production or jewelry or whatever, you can recognize that the computational work is behind it in a way. And I think that the role of computational designers should be more recognized, should be more important than it is today. We were joking about how that sometimes we are like they imagine us like nerdy geeks working in the isolated and background offices, or sometimes we are just called like the render guys or the grasshopper guys. But I think that we should, and the communication, also the magazine should do it. Actually, it should recognize that our work. And I'm one of I'm one of the lucky ones. No, yes. we should sex up the image of computational design in a way. So if you think that let's come back to the music, today there are music producers that are most famous than artists themselves.
I believe
Calvin Harris, Mark Ronson, Andrew Watt. They are all, sometimes they are more famous than the artist itself. And I can see this. And I was talking about the word vocabulary because I think it's very important, because today you can see in architecture production and also in industrial design, once again, you can recognize the vocabulary of computational designers. I'm in the business since 2009, more or less, and I personally know people that they work behind the company sometimes, and I can really recognize pieces of them. I can recognize their touch in a way behind the productions. Right. So I believe that it's not possible to think about the future of architecture without this new important professional behind. Also because the challenges, they will get more and more like complex. We are like going toward the AI era. The amount of problem to solve with products and with architecture will be more and more complex. So you cannot like distinguish, you cannot separate the architecture with and computational design. So that's my point of view. I can really see and recognize this kind of like, let's say, analogy between the music world and and the architecture ones.
Yes. Do you think at first there was a big challenge to like convince people to use computational, and what is the to show them what is the benefits of computational design? At first, I think those first years, like 10 years ago, 15 years ago, it was a bit challenging, right?
Was challenging, like first of all, because I clearly remember a story that
because
when
you are from the first generation of those guys.
I'm old enough. I'm old enough for
no,
telling you
old,
some story.
Yes.
Well, actually, I remember when I was teaching years ago, and someone called me the render guy. I never done one render in my life. I'm not good in doing visualization, but this is just a way for saying that there was a kind of misconception. So computational design was like, in a way, was like confused with the use of software, more or less. And so there was a kind of the people they were skeptical, but before being skeptical, they just consider computational design like one of the 100 tools available out there, something between AutoCAD or rendering tools or something like that. So the first stage actually was like that, just another tool. There is just another software on the market, and some nerdy geek able to play with it. The second stage was, if you think about the first work about the pioneers, like the big offices like Zadid, that in a way they really pushed the boundaries using tools, but once again using strategies, computational strategies. So they changed the world that we knew at that time. I also see, for example, when I'm outside and I can see a new car like driving in on the street, I can recognize signs that they come from the architecture, and we have this kind of mutual hybridation architecture that, for example, like influences automotive and the opposite. And the second stage was people, they were skeptical about the complexity, which was an apparent complexity, and we were discussing about it the last time, when we were saying that that was more or less the cosmetical stage, like representing complexity. And so people, they were just skeptical, and someone really rejected, and they say, no, we want to keep it simple. We don't want we don't want to face this kind of complexity. But then realize everyone in the market, once again, from architecture to footwear, that today you cannot really manage the complexity of data, because we are working on data. The drawing itself, something which it's like a common thread in my work and also in my conferences, the drawing itself is no longer a way to predict the result. So if you cannot just predict the output with a drawing, with a simple, when I say drawing, I also say a traditional digital model, you need to manage complexity through the algorithmic and the computational complexity. It's the only way for like understanding, managing data, and like getting a kind of result which is not only one-to-one connection, but it's something more complex. So now I think that we have in a moment where everyone is understanding that computational design in a way is the important is the answer. And once again, we will recognize, I'm sure, and I hope so, that we will see once again important computational designer nearby let's say the artists in a way, or the architects, that they have the vision, they have the culture, and they can actually design a building, for example.
Exactly. Someone from Instagram just told me computational designers are just like engineers. Do you agree or disagree?
No, I totally disagree. Because to me, the quality, we have to think about what a computational designer is. It's not easy to give an answer, because we don't know actually. There is not a common, let's say, definition about that. We can like talk about it actually. We should think about qualities. So technical skill, and so basically something which is closer to the idea of engineer stuff. It's one of them, but I think that we should have, as computational designer, we should have technical skill. We should have a vocabulary. Vocabulary means that you have your personal voice and touch, the way you combine things, the use of certain strategies, for example, a vision behind. If your vision is about sustainability, if your vision is about managing problem, you should have a vision behind. For example, I also in my Instagram page, you can see that I put something which is seeking beauty through technology, which is probably very ambitious, and but you should have a vision. For example, my idea is always to get beauty. Also, if beauty is a ghost word, you cannot describe it actually. And culture. If you one of the ability of computational designers is like flowing from an industry to another, and that's possible if you have a design culture. You should be passionate of your work. It's not only about I spend the 60% of my time reading books about music, architecture, or whatever, and the other time in like improving, of course, my skills in terms of coding, scripting, trying to do new stuff. But to me, it's like a kind of a holistic, I don't want to exaggerate, but a kind of Renaissance figure that blends together the technical part, but also the design culture together.
Exactly. That's right. Here I have another question, but I will just show this one first.
Okay,
this is your book.
I remember. I never read it.
Yeah.
I never read it. But I
you never read it? I have the signed version. Yeah.
Yeah, when we met in Milano.
Milan, yes. Thank you. And I just want to ask about this book. What happened? You just fall in love with the idea of writing a book, and because in those days everybody is just trying to learn something and to do something for themselves, but you did something for others, and this is very important. And this is something like a Bible. This book is a Bible for every designer, for every architect to start his career, and somebody just trying to create videos or trying to make workshops, but you did something different, and this book is very valuable in the computational world. What happened? You just started writing the book.
It's a part of my story in a way. I started like working in this field when I was, let's say, old enough. So I'm not once again, I'm not a geek. I'm not. I started doing like three-dimensional modeling when I was 27, 28, more or less. So I didn't start with that. And for me, I really struggled to understand. At the beginning, I was super fascinated by the computational design world, by parametric architecture, and in general by this kind of new avant-garde at that time. And so I started reading everything.
Right.
And when I really, when I decided to study in depth the topic, I realized that there was like a few things at the time, of course, a lot of videos, a lot of papers, documents, instruction manuals from software. Also the software background was different. Grasshopper was like really a new bird at that time. And so the first thing was like I tried to organize my material at the beginning in order to understand it. Right. And when I basically had a pile of things, of papers or whatever on one on top of the other, I said, but actually I should share this kind of work of organization. And I remember that I simplified everything. I started to write something that was easy to understand for everyone, not for like computer expert, for everyone. everyone in the architecture design field, of course. And so I came out with my first book, which was Parametric Architecture. Actually, it was like released in Italian, Architettura Parametrica, and then later on was translated into English. And after that book, then in a way it changed my life. I started doing like lessons in Italy before and then worldwide, and I started teaching. I had a lot of events and relationship with students worldwide, and so that in that moment I realized that I should like create something more advanced, something but not just advanced in terms of topic. In that moment, the idea of valuable tool which was not only focused on Grasshopper itself, but basically the book like describes a set of strategies that you can do it also by hand in a way. There is more like computational and algorithmic thinking than Grasshopper itself in a way. And it took like 2 years enough, also almost 3 years in order to write it, like of daily writing. And I felt the responsibility of like creating something that was able to, the proof of time in a way, and not only the latest manual for the software, but creating a kind of once again the idea of like sharing my idea of algorithmic thinking, but also giving a kind of super simple history of the like the evolution of tools from drawing to the algorithmic diagrams in a way. And I also was also the opportunity to collaborate with many people. The book has the contributions from architects, designers, researchers from many like institutions and companies. Was also the opportunity to have a kind of dialogue. And I think that after 3 years of work, and was like totally destroying for me in a way, but I'm proud of I'm very proud of the final output, and I'm very happy when young generations, so the young students, they really appreciate the effort behind the book. And I'm very happy when someone like send me a message, and they wrote me sometimes on like, not sometimes, actually very often, and I'm very proud, and I really don't take it for granted, and I'm very happy to receive messages about that sometimes the book that changed their life, their design life, of course. It doesn't have power for changing life in general, but basically there is something, I hope I'm not pretentious on that. I always try to put also in a technical book a positive message. And the idea is not only you can master a software with those like topics and skills that you can get from the book, but it's also a way for saying, I always think about a word that I like so much, which is hyper meritocracy. I think that social network today, and also the new design communities, they are like in a way there is a kind of a hyper meritocratic process. Only if you really have a merit, you can be recognized. Because we are like, we were also discussing about that. The competition in architecture today is not only about, the last fashion idea, the last cool idea. But today, if you want to succeed in the market, you should merge your vision, your like dreams, your ghosts sometimes, with a more mature content, which of course is blended with the technology. Today, everything is technology. You cannot live without it. And we are really understanding how important technology is nowadays. And we are really, we are here, we have people, we are speaking with people, and it's very important. Architecture cannot ignore the importance of digital tools today. For example, I wrote an article like a few weeks ago, and I was saying that probably Le Corbusier right now, when he wrote Toward an Architecture, he was like looking to airplanes, cars as an influence for architecture. You know, the machine habitaire.
Right.
And today, I'm sure that he will look at smartphone apps, probably websites. We should like be contaminated not only by design itself, but once again, we are like exploring new ways of communication, new ways of interacting people, and finding new ways for like enhancing our profession. And also architecture, I think, will be, I'm sure, deeply influenced by the technology world and the digital world also.
Exactly. So a lot of people asking about the name of the book. It's Algorithm Aided Design by Arturo Tedeschi. And I will put out the link at the description
of the Thank you so much.
You're welcome. And everybody who's just looking for it, you can click on the link and just enter on the Amazon. You can buy it. And also we'll announce it soon on Parametric Architecture channel as well. And there's a good question from one of our followers, which says, she asks, would be nice to hear a short list of books as a recommendation. Thanks for webinar. And Didam asks.
Well, I have a set of books here, so I can do it live. I was not prepared.
Sure.
And I can do it
now.
I can do it right now. Yeah, for example, okay. Well, when people say, sometimes they ask me, I don't know, can you suggest something about Grasshopper or like algorithmic modeling? And I say always you should start from geometry. The important thing is like managing geometry, differential geometry. Otherwise, you cannot play with the tool itself. The tools, they are just a way for like like speeding up processes, but basically they are processes, they are in our mind. This one to me is one of the Bibles. I hope you can see it. It's called Architectural Geometry.
I see.
By Helmut Pottmann, which is a master in by Bentley System. This is a book that was published, I think, around 2006-07, if I remember. It's a great one. I really love it, and it's like more than an overview of on architectural geometry. So all the topics behind the shape, the control of architecture and design complexity. Everything is about shape. Everything is about geometry, from NURBS to meshes to surface continuity to all the topics that are, once again, I was talking about vocabulary in a way. All the technical vocabulary in a way is well explained in this book that can be read also, I would say, on two different levels. You can also, you can really go deep in the contents, or you can just enjoy the book. I mean, not just looking at pictures, but you can also enjoy it in a more, let's say, superficial way. To me, is a must-have for computational designers. There is another one that is here, which is the new. This is called The New Mathematics of Architecture. Is Thams and Hudson, publisher. Okay, this one. This is also interesting because there are many examples of architectures combined with the mathematical, once again, aspects and DNA behind them. So it's, once again, it's important for the technical. I was talking about qualities about computational designers is for the technical, in order to improve our technical skills and in order to have a global vision on the topic. And once again, it's also important to the hybridization with other topics which are not only strictly technical but also in general. You can see also here, for example, this one, which is called Big Data.
Big Data.
It's one of the, it's a best-selling book on data management. It's not strictly about computational design, but to me, this one is like one of the most important topic of the next future.
Next future.
And let's say just 3 books, but the of course is like in general this is just a way for giving a kind of tips. Geometry, always you cannot stay in our, let's say, in this field if you don't have a geometric control, blended with mathematical aspects, of course, scripting, ça va sans dire, as French people say. And also you should be open to the new trend topics. Big data is one of them, but AI is one of them, of course. But also I suggest to read about the smartphone apps, about the new platforms. Everything is important because today everything is really connected.
Exactly. Thank you so much, Arturo. I will leave this chat in a few minutes, and I just want to say a couple of words. Then I will leave soon. So, guys, I will put the link description. I will put the link on description. You can just click on the link, and also I will add the link of the books that Arturo suggested. You can also click from the link in description. And if you're gonna share this webinar on your social media as well, make sure to tag Arturo, me, and Parametric Architecture page as well. Okay, and thank you. Do you need anything from me, Arturo?
Sorry?
Do you need anything
Sorry, I didn't
from
hear
me?
you. It's perfect. Thank you so much. Thank you so much for hosting this. Thank you so much for having me here. It was really a great pleasure. Thanks also for the question, guys.
Thank you. I really appreciate your time for sharing your knowledge for free. Thank you. Goodbye, guys. I'm leaving you, Arturo.
Okay, so the idea here is like today I want to show you something about the modeling of complex architecture, which is basically the great curved roof of British Museum in London. So we are going to do this project into 2 separate steps. There is a first part which is absolutely basic one, so it will be a kind of introduction to mesh modeling in Grasshopper, and also with the use of Kangaroo Physics Engine. The second part will be, let's say, a bit more advanced, and it's about the paneling tool, which is a set of components available in Grasshopper in order to create complex grids, and it will be the second part of the exercise. I was talking before about the role of computational designers as in this analogy with music producer. For example, the British Museum roof was designed by Norman Foster with the help of Christopher Williams, which is a British mathematician. So once again, I always see this kind of featuring, once again, David Bowie with Brian Eno. In this case, the role of Christopher Williams was super important in order to shape, in order to create the mathematical complexity, the geometric complexity of the British Museum roof. So I'm going to set my environment, just a few seconds. I suggest to open Rhino and Grasshopper. Meanwhile, make sure that you have already installed. Of course, you can also rewatch the webinar later on, but we are going to use Grasshopper, of course, Kangaroo 2, which is already embedded inside Grasshopper, Lunchbox, Weaverbird for mesh management, and in the second part, we are going to use paneling tools. So just 1 second in order to set my screen and my environment. Okay, now you should hear my voice again, and you should also see my screen. Hamid, I kindly ask you if you can give me a confirmation on WhatsApp if everything works, since I cannot access the chat right now. Okay. Okay, basically we are going to start with a 3D model that I already prepared. Don't worry, you don't have to model all the building, as you can see here, but this is just a way for giving you a kind of context. So this is the British Museum in London, and actually we are going to do the process in order to create the final geometry. As you can see here, we are going to create the roof like this, which is a kind of steel diagrid based on square space with a cylinder inside, as you can see here. Okay, so in general, when you want to create a three-dimensional grid in Grasshopper, it's in general is a very easy procedure when you are dealing when you are dealing with simple, let's say, flat surfaces. So, for example, if I'm creating, let's say, a flat surface here. We can like import the geometry. And then, for example, using the Lunchbox set of tools in the panels category, we have many tools, for example, diamond panels, allowing us to create complex grids on top of our surface just by playing with the U and V parameters, as you can see here. So you can play with this, and it's super easy. It's more complex, of course, when you have something like this. If we don't have a flat surface, but we have a geometry with a hole inside, it's not easy to create a diagrid on top of it. If I repeat the same procedure, for example, on a flat surface with a hole inside, the diagrid, and I'm going to show you just for example, if we have something like that and I create, let's say, a hole inside, and then I'm going to trim this one like this. As you probably already know, we have a surface. It's called a trim one. A trim geometry is a surface with, in general, doesn't embed the mathematical domain. So in other words, if we have something like that, with a hole like this, the mathematical grid is also, let's say, inside our hole. So if you use diamond like this, okay. So as you can see, our grid, it's also inside our hole. Okay, so in order to create a complex grid when you are dealing with trimmed surfaces, it's like it's different, and we have to rely on different strategies. For example, let's do something more complex directly on our building. Okay. So the aim here is starting from two main curves. We have a rectangular one here and a cylinder here. We are going to actually to replicate, to do again the process that computational designers use in order to create the three-dimensional grid on top of the like great curve here. So I can turn off the building for a second. As you can see, we just have one rectangle here and one circle. More or less, the dimensions are coming from the actual like dimensions. More or less, we have 73 meters and 92 meters for the second distance. And here we have a radius which is about 44 meters. It's not important to have exactly the same dimensions, but more or less I'm playing with this kind of values. And then my Rhino is set on meters. So no tricks. We can create the whole structure, of course, in a simplified way, but more or less we are going to create the actual structure starting just from two simple curves. So let's go to import our geometries in Grasshopper. So we can use the curve component. We are going to set the first circle here. It's always important to rename components in order to have like a more organized script. So I can write, for example, circle here. So we know that this one is a curve, but it's also the circle, and we can do the same thing for our rectangle. So Control C and Control V, and I can rectangle here. So set one curve. Sorry for the misspelling here. Okay. So we have the circle and the rectangle here. It's always important when you import curves from Rhino to Grasshopper, it's important to reparameterize the curves themselves. So just right-click here, reparameterize, right-click here, and reparameterize. Okay. Reparameterizing a curve does mean that if you have a curve with a length which is equal to L, if your curve is not parameterized, it means that you can, if your curve is parameterized, it means that you can select the points on your curve using just one single parameter, which is called t. So if t is equal to 0, you have the start point. If t is equal to 1, you have the end point. When you set reparameterize here, you are like normalizing the curve into an interval between 0 and 1. So for example, if you want to select this point here, or this point here, or this point here, there will be values between 0 and 1 in terms of t coordinates. But we are going to do something about that in a while. The second thing to do is like we want to divide our circle into 8 parts, for example. So I can use a component which is called divide curve. So this one goes here. And of course, I'm going to set my value here. So I'm dividing into 8 parts, and of course, it is like divided symmetrically, as you can see here. And as a second thing, I want to split my circle using the points that you can see here coming from the divide curve component. So when you want to actually split something. In Grasshopper, we don't have a command which is called split, but actually the command is called shatter. Okay. So shatter needs the curve to be split. So this one goes here. And in order to actually split our curve, we need the t parameter I was talking about before. So basically the t parameter is connected here. So in other words, if you have, let's say, a curve like this, and you want to split it in this point here, you need to provide the t parameter, which is, once again, between 0 and 1. So more or less, this one will be something like, I don't know, 0.2, for example. Actually, 0.5 is not exactly the midpoint, but this is a, let's say, vast topic. We cannot cover everything about the curve parametrization, but basically, if you want to cut something, if you want to cut a curve using a point, you need to get the t parameter of the point itself, which in this case is generated by the t output. If you connect a panel here, as you can see, we have the t parameters of our points between 0 and 1. So we will have 0, 0.13, 25, and so on. Okay. So basically now we have our circle. So from shatter, actually, from the S output, we are getting the individual segments of the original circle. As a second step, we are going to do something similar for our rectangle here. So instead of dividing, since the rectangle is basically a polyline, is a closed polyline, the first thing to do is like exploding the polyline. So like this, we are getting as an output the first, the second, third, and fourth segment, like this. And also the vertices from the explosion itself. If you check this output, as you can see, we have like 5 points because we have an overlapping of this geometry. Another ways for selecting, if you want to get 1, 2, 3, and 4 points, for example, you can use a tool which is called discontinuity. So I connect this one here. And now we are getting only 1, 2, 3, and 4 without any overlapping, because when you use explode, you are actually exploding the curve, so the start point and end points, they are overlap. That's why we have we had 5 points before. Okay. Second thing to do, I want to basically get 8 points as I did for the circle. Here we just have 1, 2, 3, 4. And my idea is like selecting the midpoint of this segment, midpoint, midpoint, and midpoint. In order to do that, there is a component which is called point on curve. We can connect it, this one here. And as you can see, we have now 1, 2, 3, 4, 5, 6, 7, 8. So 8 points on our circle and 8 points on the original rectangle. So with the same logic, I can use shatter also here. So make sure that your component is parameterized here. So I want to shatter this one. And I want to split my rectangle using the 8 points coming from this guy here, but also this guy here. So the first thing to do is like merging them together. So from this one, I'm getting 4 points and 4 points from this one. So merge component. Okay. So inside this merge component, now we have 8 points. But as I mentioned before, we cannot use, in order to shatter, in order to split my curve, those points, because they are expressed in x, y, and z coordinates. We need to find the t parameter of each point according to the original curve. So when you have to do this kind of conversion, in other words, let me sketch something. If you have this point is expressed in x, y, and z coordinates, of course. So we have x, y, and z. But we also have a t parameter, which ranges between 0 and 1.